This is Algebra 2 at Trig. We're working on Unit 2B.1, Properties of Exponents. Now, there's a handful of properties here that we work through, and then we practice several problems at the bottom. We have the product of powers. When we are multiplying exponents that have the same base, we are going to add the exponents. So that would be the product of powers, adding the exponents if you're multiplying the same base. The quotient of powers. When you are dividing two bases that are the same, the bases have to be the same. In this case, they both have to be x's. You are going to subtract your exponents. And that is x to the third power. So another way to think about this could be written as x times x times x times x times x. That is x to the fifth power, means that you're multiplying 5 x's in a row. And x squared means that you're multiplying two different x's together. And you can cross out your x's, and you're left with 3 x's on top. So because they're multiplying, we say x cubed. If they happen to be 3 x's that we're adding, that would be x plus x plus x. That's when we use 3x. But because these are multiplying, we're going to use the cube. The power of a power. Here we're taking a quantity, in this case it is x squared, and we're going to cube it. One way to think about that is that you are cubing x squared, which is x squared times x squared times x squared. And you know there we would add the exponents all together. The shortcut of 2 plus 2 plus 2 would be able to say 2 times 3. This should be x to the 6th power. Notice that we are not raising the power of the 2. It's not x to the 8th power, but it's 2 times 3, which is 6. Because x squared, which is being cubed, means that you're going to write it 3 times, and when the bases are the same, you add the exponents. 2 plus 2 plus 2 is 6. The power of a product. So here we're going to have perhaps 2x squared cubed. So very similar to the previous example, but now we have a product. And in this case, we are able to distribute that exponent into each of the exponents. So if there's no exponent written, it's going to be a 1. So the 3 times the 1 gives you 2 to the third power. The 3 times the 2, like we did before, gives you the 6 as a power. And that's a total of 8x to the 6th power. A common mistake here is people say 3 times 2 is 6. So you say 6x to the 6th power. But that is 2 to the third power, which is 2 times 2 times 2, which is 8. Same idea with the power of a quotient. And if we put a power on the backside, so we have x cubed over x, which is x to the first power, right? When it's not written, it's x to the first power. So one way you could think about this is either simplifying the inside when appropriate. Here, I'm going to change up something because we have multiple ways we could do this one. Let's change this x into a y. So now we can't simplify. We can't just rule out the x on bottom to call it x squared. Now we have a y on bottom. We cannot simplify what's inside the parentheses. So all we have an option to do is to distribute the exponent into each of the exponents inside the parentheses. So that's x to the 12th power over y to the 4th power. Because the bases are different, the x and the y are different, you cannot work with the 12 and the 4. You've got to keep them separated. That's as simplified as you can go. Working with the negative exponents. If we have x cubed over x to the 5th, that would give us x3 minus 5. And because we are subtracting exponents, because we're dividing. Well, when you're dividing, that would give you x to the negative 2. Now, if you have a negative exponent, that means that you are going to place it into the denominator and make it positive. Also, know that if you have a negative in the denominator, then you're going to bring that up into the numerator. If you have a negative in the denominator on your exponent, we don't want negative exponents. There's not really a time where you're going to write anything with a negative exponent. So change that and bring it on top of the fraction as a numerator with a positive exponent. And then our last one is the 0 exponent. That would be like x to the 0 power is going to be a value of 1. Or 7 to the 0 power is a value of 1. 2x to the 0 power is a value of 1. Anything to the 0 power is a value of 1. So now we just go down and practice some problems. So here we have parentheses. You could call this one the power of a quotient. We can distribute that exponent in. So that's going to be 1 to the negative 8th power. Going to become 3 to the negative 4th power, because we multiply exponents when we're raising a power to a power. Well, these are both negative, so they're not happy in either location that they're at. So you're going to bring this negative exponent up to the top. You'll bring the one that's on top down to the bottom. And then we would just have 3 to the 4th power, because whenever you multiply 1 times 1 times 1 times 1 times 1, you're always going to get 1. So when a denominator is 1, we don't have to write it. If you're working with powers that are bigger than values you know, you can leave it as maybe it's 7 to the 8th power. You can leave it. You don't have to calculate that all out. But when they're more reasonable, ones that you might be familiar with, 3 to the 4th power. There are 4 different 3's. 3 times 3 is 9. The other 3 and 3 is 9. So 9 and 9 is 81. So 3 to the 4th power would be 81. Coming over to example number 2. Now here's an example where all the bases are the same. We have W, 5 is our power, and we're going to add that to the next exponent because the bases are the same. And we're going to add that to the next power because all the bases are the same. We add the exponents. So that's going to be -3, and you're adding that to the 6. So that's W to the 3rd power. Because the bases are the same, they're all W's, you can group them together. And that's where we come up with W cubed. Here we have another quotient with an exponent, so we can distribute our exponents into that. Becomes C to the -2, D to the +8. We're going to move the C to the denominator. I often like to write that first because it's alphabetical order. Now it's a positive exponent on the 2 because it moved from one side to the other, changes its value. And the numerator is going to have a 1 on it because the value in front of C to the -2 is just a 1. There we have it. Here we're simplifying. Now we have multiple different variables. Some people get confused as soon as there's extra variables. Like you look down here and there's a whole bunch of variables. Break it down to one set at a time. So this is just working with the A's. And then work with the B's on their own later on. So I put it over 1 just because a fraction could be always over 1. Or a fraction will always have 1 as a denominator if there's not a number written there. There's no B's on bottom, so I just represent that placement with a 1. So here, if there is a negative exponent on top, we're going to bring the 3 to the bottom. So this is going to be 1 over a to the 8th. And the B is going to be on top, squared. So we have B squared over a to the 8th. Now, a common mistake that we get here with example number 5, people think that they need to FOIL this. This is not a foiling question. This has a 7 in front. This has a 1 in front. So we're just multiplying those two numbers. So we get 7. We have a y squared and a y to the -4. So if you want to think about those two things working together, you're going to work with the y's, then you're going to work with the z's. So I'm just rewriting it, bringing the y's together and bringing the z's together, because that's how you need to mentally think about this. The negative exponent means that you're going to place the y into the denominator. In this case, you're going to place the z into the denominator because it has a negative exponent. You have more exponents on bottom than you have on top, so you're going to do 7 over y squared and z to the 4th. The z has a larger exponent. They're 4 larger, so there's going to be more z's on top. For the y's, the 4 is larger than the 2. There's 2 bigger on bottom, so So you have 2 left on bottom. The 7 doesn't get connected with the y. The 7 is separate, the y's are separate, the z's are separate. Now with the positive and negative, the negative 4 went to the denominator. We had the positive on top, we had the positive on bottom, and notice that there are 2 extra y's on bottom, so it's going to stay on bottom. You have 2, in this case you have 4 extra z's on top, so the 4 is on top. Here, just like the other problems we've done, you have a choice on how to solve this. You can either simplify the middle, the inside, and then work with the exponent, or you can work with the exponent first. We have a few examples like these. I'll try to do them in different formats, but I'll do this one first by distributing my exponent in. And look what I have to do to the 2. A common mistake is to forget that 2. This exponent's got to come in and multiply the exponent of a 1. So this is going to become a to the 6th power times b to the negative 3 power, 2 to the 3rd power, a to the 9th power, and b to the 6th power. Now you're going to group up and just work with the a's. There are more a's on bottom than there are on top. There are 3 extra a's on bottom, because 9 is bigger than 6 by a number of 3. So there's 3 extra on bottom. The negative exponent's going to go to the bottom. So you have 6 on bottom, you have 3 more on bottom, so that's a total of 9 on bottom. And the 2 to the 3rd power is also on bottom. So it looks like everything reduced to the bottom, and we leave the numerator with a 1. This example over here is very similar. This time we'll do this one different. We'll work with the insides first, and then we will use the 3 on the outside. It's your choice. So you could say that we have more x's on top than we have on bottom. We have 1 extra x on top than we have on bottom. We're going to bring the negative exponent to the denominator. So that is going to be y to the 8th power in the denominator. Now we're going to work with the exponent, the power on the outside, which is a 3. And we distribute that to both of the values, so it's x cubed y to the 24th. So with the x's, I subtracted exponents. I said 4 minus 3 equals 1, because 4 is your exponent, 3 has the same base, so 4 minus 3, because it's a fraction, is 1, so that's why it's x to the 1st power. Over to our last one. Again, it gets confusing when there's so many of them. Just break them down individually. That you're going to work with x and x squared. You're going to work with y to the negative 1 and the y. And then here you're going to work with the 7. You're going to work with the x. And you're going to work with the y. So they're all considered separate. So here we can reduce it. Notice that there's 1 on top and there's 2 on bottom, so you have an extra x on bottom. The negative exponent means you're going to go to the bottom, so now you have a square on bottom. You have your 7, that's on top of the fraction. Here you have an x cubed. So if you have an x cubed on top, we'll write those out. And the negative exponent is going to go to the top as well. So that is now y to the positive fourth over 1. So here you have x cubed over x. When they're multiplied, it's all one big problem. They're not separate fractions necessarily. They're all one big fraction. So you have x cubed over x, which leaves you an x squared. You have an x to the fourth over x squared, which leaves you 2 extra y's on top. And the 7 is sitting in front.